Today we're going to talk about conduction and convection. Conduction is a process by which heat or electricity is transferred through a substance by the movement of particles, but today we're going to be focusing on heat. So conductors allow heat to pass through them very easily. Solids are very good conductors. Metals are very good conductors as well, because the particles in metals are close together, because metal is a solid and particles in solid are close together. But also metals have delocalized electrons that are able to move and transfer heat energy. So I've got some metals here. I've got steel, brass, aluminum, and copper. And we're going to predict which one the thermal energy will be transferred the easiest on. So which one is the best conductor of heat energy? I want you to pause the video and to write which one you think, and then you continue the video after that. I'm going to pour some hot water in my beaker. I'm not going to pour too much. And then I'm going to put my metals in. And then we're going to watch to see what happens as the heat is transferred. So you should be able to see the color changes. And from this, you should be able to tell which one is the best conductor of heat. So from this experiment, we can see that copper is the best conductor of heat. This is shown by the color changes. This tells us that the heat travels through the copper metal quickest, followed by the aluminum, as you can see the color changes, then brass, whose color changes further down, and steel. So copper is the best conductor when compared to aluminum, brass, and steel. Is your prediction correct? Today we will be talking about convection. Convection is the process by which fluids conduct heat or thermal energy. So what I have here is a convection tube, and I am going to add heat to one side of the convection tube, and I'm going to add potassium permanganate crystals to the other side of the convection tube, and we will see what happens. I've added heat to one side of the convection tube, and there's water in my convection tube. Water is a fluid. So the particles closest to the heat source will gain heat energy. They will get less dense and they will start rising to the top. The particles that are at the top, they're cold, so they will sink to the bottom and it will create a convection current. So I'm going to add potassium permanganate crystals to the convection tube, and we will see that the potassium permanganate starts to spread as the fluid heats up, and it will create what we call a convection current. So you can see the particles sinking, colder particles sinking, and you will see the warmer particles rising to the top. So you can see that the potassium permanganate starts to spread out. So the particles sink to the bottom. So the more dense particles are sinking to the bottom, as the particles closest to the heat source will get less dense and rise to the top. And this creates a convection current. This creates a convection current. So now you're able to see that the potassium permanganate has spread throughout the liquid. And this is of course because the heat has been transferred throughout the entire liquid. Even though I only added it to one side, the particles move and allow heat energy to be transferred throughout the entire liquid.